Good morning to all. So today we are going to discuss about the differentiation of a single integration and a double integration. So already we know that 12th standard you learned about the integration and then application of integration. What is the application of integration? Anyone application of integration? We find out using integration. Area, right? Area. Application of integration. Go to area. This one. So in same thing, we have to. We are using also integration. The accurate value. See, for example, the 2-dimension. We are using that area bounding is using integration. That is single integration. So now we are using in that double integration. So with using dx into dy. So double integration we discuss with the same value of x value and also the y value. Is that clear? So in this particularly the double integration and the triple integration we are using the volume. Okay. So why we are using that integration with using the finding the value of 3-dimensional area and then volume. See, we need the perfect value. See, always we are using that integration and differentiation. It is a very accurate value. We need the accurate value. We have to only choose. We have to choose that integration and differentiation. That it is the very powerful because in that normal equipment, whatever it will be, we are using that. That is no problem. But in case of using that using of surgical value, surgical. See, we using that surgical blade and then surgical equipment. So that and all, we are using that some other values of without using the integration and the differentiation, the values definitely will be differ. Okay. So we are using that bypass surgery, right? So bypass surgery we are using that some other we are making that surgical blade and scissors everything. We are making some other using that some other application. Definitely the making errors it will come. So if it is errors it will come. In case of errors will come, definitely it will damage the system of like in our skin. So that is a very important thing, right? So when we choose the integration and differentiation, did you know that the difference, always the differentiation is like the difference, and then integration is the sum. So it is the reducing error. The error will be increased or decreased. So because the error may be the plus value or minus value. For example, we are making the robot. We making the robot. So you give the condition, the making that anyone will take. So in this taking this mobile, in this this knee will be going to the 30 degree. We have to give the 30 degree comment. Okay. So if it will take the 30 degree, something will be error will be 31 degree or 29 degree, right? So if it is making anything error, so it will come or 31 degree or 29 degree. So if it is 29 degree, we have to increase the error, right? So if we want 30 degree, right? So if it is going to the 29 degree error, then we have to make the error plus value, right? We have to take 30 degree. So if it is making 31 degree, we have to reduce the error, right? So 31 means 31, 30, making the error minus, then it will be get the take 30 degree. You understood? So errors there are two types. One is we have to increase the error, and another one is we have to reduce the error. So in this basically in these two tools that we are perfect value, we need the perfect value. One thing we have to choose that integration and difference. Okay. So in this minor error, how many minors of error? See, in this 0.000 will make it hundreds of 0. After that the 1, 2, 3 value. So it is maybe it is in our we are seeing that normalized, there is no error, but it is the error. Even though 0.00000, 1 to 3 is also a error. So that error is also we have to reduce it. So So that time we are using the differentiation and integration. So this is the difference between the differentiation and integration. And particularly we have to choose integration, application of integration. That is, for example, we are making that area. So area, wherever you see that the 1 hectare is the 1 hectare. Okay. So and then see this room, there is a breadth and a length. Okay. So if you standing here or there, okay. So value is same, but the way of view is different, right? So we need that dx into dy and dy into dx. We need to the both the values dx into dy. Maybe you are standing here, so view of this way. And if you stand there, so we have to change the axis, right? So here dx into dy. If you stand there means dy into dx, right? So that integration should give the perfect value. See, it is the realistic example. You have to see that your portrait video and as well as landscape video. Did you notice that landscape video? And if you see that in a portrait, the values, all the sides of the values less than not only the one side, all the sides, right? So that is the perfect example of double integration. So the value, see the value, we have to see the picture to all the sides to elaborate. Then we are making use of a double integration, that is dy, the two axes of dy and dx. Okay, thank you.